Hey, hello, everyone. My name is Alex. I'm working at a company called Zencoder. I'm officially head of ML and DevOps, but because it's a startup, I also wear a lot of different hats. I also double as DevRel, and in general, Dev Ask Me Anything. Today, I will be talking with you about AI agents, or about AI coding agents specifically, and we will see how you can create them on your own, and then we will see how you can also implement them, how you can use them in your everyday life, in your coding, basically. So first thing first, you probably heard a lot of headlines, a lot of news about AI agents or AI in general replacing the developers. For example, here, Mark Zuckerberg recently said that AI will replace mid-level engineers, I think by 2013, he mentioned. And this essentially comes from two main sources. First of all, of course, models become better and better. So, for example, here, this is a slide of comparison on different benchmarks of different models which came up recently. For example, here, Gemini 2.5 Pro is beating, of course, the older models on different benchmarks. Specifically, here, we're interested in these three highlighted datasets, which are related to coding. But the problem is the benchmarks on its own are not usually very relevant to the real life world, to the real life work of developers, because, for example, either polyglot requires you or AI to just modify single file, a single method, whereas in real life world, you usually require to implement changes across multiple files, or even multiple directories. So it's not always directly. The results from the benchmarks are not always directly transferable to the real life world. But that's, of course, not the only source of those headlines. The other one, which is the main topic of our today's presentation, is AI agents. Now, first, we will, of course, talk about what is agent. Then the main chunk of this presentation is about coding the coding agent, and then we will briefly talk about what the future holds for the developers. So yeah, let's basically build an AI which will potentially replace you. So first things first, let's talk about AI agents in general. And throughout the presentation, I will be interchangeably using both terms, AI agents and AI coding agents, just because all the principles which we will be going through today are applicable to both AI agents in general, but also specifically when they are applied to coding. Now, broadly speaking, AI agent can be defined as a software that performs tasks on behalf of a user. And you might say that basically any software, right? So even current coding assistants like GitHub Copilot, for example, they essentially perform tasks on behalf of the user, right? You can ask them to generate code, you can ask them to refactor code, ask to generate code or whatever, and that's basically them implementing a task on your behalf, right? So you can, generate 10,000 lines of code in 2 minutes and then spend a couple days on debugging it just by simply pressing tab for a couple minutes. Now, the main difference from regular software which agents have is essentially they follow those agentic design pattern. First of all, they can use tools, and those tools could be pretty much anything. It could be a web search, it could be some local file manipulation, it could be sending a request to a RESTful API, and so on. They can also do some planning steps, so they can essentially create a plan and then follow that step to achieve the goal. They can also reflect on those plans. They can reflect on their work or the work of each other. And this also brings the multi-agent collaboration, because agents can essentially, for example, one agent could critique another agent on their plan, or they can work together on creating a multi-stage plan and then reflect on it and then iteratively work on improving that plan and so on. And basically, those four patterns, which we will see in action going forward, they differentiate AI agents from the typical software review. Now, you can think about agent as basically a Roomba vacuum cleaner, and the software itself on the Roomba is an AI agent. However, if the Roomba didn't have any tools, anything else at its disposal, it would only be probably able to just point to the patches of dirt on the floor, and then that wouldn't be very useful for you, right? Those vacuum cleaners wouldn't be very helpful for you. Now, in reality, Roombas have, first of all, tools, right? They have tool use. They have wheels. They have brushes, which help them move around and clean the floor. They also can do planning, so I can plan ahead on what what's the best route they need to take to perform better cleaning. And for some reason, ChatGPT thinks that robot vacuum cleaners move in these weirdly shaped patterns. But yeah, I guess AI sometimes thinks weirdly. Yeah, there is, of course, no multi-agent collaboration, at least yet, unless you count this multi-agent collaboration. But maybe in the future, Roombas will be able to talk with each other and or with other appliances and work together on better cleaning the floor or whatever. Right. So with that, let's first actually talk about why it is important. Why those agents are, well, some say that agents potentially can replace developers. And with that, first, let's think about what developers spend their most of the time on. And spoiler alert, it's not drinking coffee. Now, based on the research done by Minelli in 2015, and even though it is 10 years old, I don't think much has changed. Developers spend most of their time on understanding. It could be understanding the code, it could be understanding the requirements of the project, and so on. And only 5% of the time is spent on actually editing the code. Now, if you overlap these with what we just discussed about agents, about their agentic patterns, we will see that, first of all, we have tool use, right? So to do editing, to do UI interactions, of course, you need to use tools. To do planning, you need to, of course, understand what you are planning about, right? You need to probably spend some time outside of IDE or maybe navigate around. For reflection, of course, you also need to understand the requirements, the code, and so on. And of course, we as developers, we usually work in teams, and this means we have multi-agent collaboration or multi-agent collaboration, where, of course, to do this collaboration properly, we would need to have understanding. We would need to probably spend some time outside of IDE, I know in Slack or whatever. We need to do a lot of UI interactions and so on. So basically, all of our work as developers is overlapping significantly with what we discussed about the agents and what they essentially stand out for, right? So basically, agents potentially, at least on this superficial level, they overlap significantly in what they are able to do in everyday in real life, right? Now, with that, let's see how we can actually code those agents. And we will finally do some coding. Now, all the code available, all the code which I will be showing today is available on this link over here, or on this QR code. And the way I structure the coding session is basically I will go through several stages, and hopefully not those stages. Basically, I will start with some baseline, which you might have already seen or experienced yourself. And then we will progressively build on top of that from simple agent all the way to multi-agent collaboration with different tools and so on. So with that, let's switch to our baseline first. So over here, basically what I'm doing is, and if you don't know Python, it's not a problem. The code itself is pretty easy to read. But basically what I'm doing here as a baseline, I'm just using OpenAI framework to call ChatGPT. In this case, I'm using GPT 4.1, the most recent model from OpenAI. And here I'm just sending the message to OpenAI, right, and getting the response. Now, you've probably seen or again experienced the same issues because models on their own, they don't have access to real life world, they don't have access to internet, they don't have access to your local machine. So they can do things like ping, right? So they don't know what's the response time for Google. They don't know what Python packages I have installed over here. Like it does provide some examples or some bash commands to be potentially helpful, right? So in this case, yeah, there is a bash command over here. There is some Python code over here to list the packages, but this doesn't really answer the question which we posed to the model. And then, of course, models usually lack up-to-date knowledge. So in this case, because it's a recent model, it does have some more recent updates because the last update was from June 2024 when Python 3.14 was still in very early days of development. So it does have some knowledge, and provide some links to potentially useful information. However, if you would try the same with all the models, you wouldn't know anything about Python 3.14 at all. And of course, if something came up recently, if something came up this year, for example, it wouldn't have any knowledge about these facts whatsoever. Now let's see how we can fix those issues first. And for that, we will go to the first sort of basic agent notebook here. Again, I'm using the same OpenAI model as we've seen before. However, on top of that, we will also be using a React framework. So React stands for reason plus act, and basically what we are doing is we are instructing the model, the LLM, to go through a loop of several steps. First, it needs to think about what it needs to perform, what kind of action or what kind of information it needs to collect to get the answer. So basically, the thought is the first step. Then it needs to perform an action or select an action, which needs to be run outside of the model to get the required information. Then we will pause. And this is basically when the action itself is supposed to happen. Then, based on this action output, the model will observe. So it will go into the observation step, and based on the observation, hopefully it will have enough information to give the answer. But if not, of course, it can go to the second loop. So it will go to the second thought, perform a second action, and so on until it gives the answer. And this can be implemented quite easily through this system prompt over here. So essentially, we are just instructing LLM to work in this loop, which I just described, of thought, action, pause, and observation. And at the end, it needs to output an answer, right? So we also provide some actions which it can run. In this case, that would be ping. And we also supply the way for LLM to call those commands. In this case, it would be ping semicolon python.org, for example. We also provide a tool for bash. So basically for running bash commands, right? So it would be bash semicolon and then the bash command itself. The same goes for the web search. So it would be able to do a web search. In this case, it's searching, for example, for capital of Portugal, although probably LLM would know this without a web search, I would hope. And then, of course, we also will provide some example session for LLM as a reference. In this case, the question would be, how many islands make up Madeira? And I live on Madeira, so it's a nice little Easter egg for that. And so the thought of the LLM would be, hopefully, that it should do a web search for the Madeira. Then the action would be the web search. Then the pause is for that actual action to run. And then based on the observation, which hopefully will provide the answer, the correct answer, it will give us the answer itself, which is 4 islands. Now, again, here I'm querying the same model in the same fashion. It is GPT 4.1. And over here, I defined 3 functions which will perform our actions, right? So we have ping, we have bash, and we have web search. Let's test them out. So over here, ping gives us 200 milliseconds, which is, I guess, not so bad. For the Python version, I have locally installed 3.12.6, which seems correct. And for the web search, it found the correct link, which is basically the link to the docs of python.org for Python 3.14. And there's a lot of text over here, which hopefully the LLM will be able to go through and give us the summary. Over here, I'm just compiling these known actions into the list, into a dictionary of actions. And then the main action happens here. Over here, we basically just define the React loop, which we just described in the prompt. So first, we will send the message, of course, to LLM. And then, based on the response from LLM, we will check if it decided to go for any action, which will be signified by this prefix of action semicolon, followed by the action itself, and then the input to that action. Then, based on action, if there is any action decided by LLM to use, we will actually perform that action based on the request. So basically, we will run the action with the action input. We will observe what happened, and we will pass that observation as a next prompt to LLM. And then, based on this observation, hopefully the LLM will be able to give us the answer. Let's see that in action. And we will use the same answers, but sorry, same questions which we had before. So, for example, here for the response type for Google, the LLM decided to call action ping, which makes sense, right? And it got the answer of 250 milliseconds, a bit worse than before, but it is what it is. And it gave us the answer, the actual answer for our question. The same goes with the Python packages, which I have installed locally. It decided to go for the pip list, which makes sense. It got a list of a lot of different packages and then summarized it for us nicely over here. And the same goes with Python 3.14. It decided to do a web search over here for what is new in Python 3.14. And it got the answer, the observation, a lot of text from the website. Let me scroll all the way down. And somewhere over here, we should get the answer from LLM itself. Yeah, over here, we got an answer with a nice little summary of what's new in Python 3.14 based on the web search LLM performed. So with that, we already can extend the capabilities of LLMs of most of modern LLMs beyond what they already know in their from their training data. But of course, it wouldn't be very handy to always just define those tools in the prompt, create, especially if we're talking about some sophisticated things like Git, for example, right? Because there are a lot of different variations of Git commands. And here where MCP comes in to help us, MCP stands for Model Context Protocol, which was introduced by Anthropic pretty recently, a couple months ago, and it basically allows for LLM to use, for us to use standardized protocol to pass information from LLM to the MCP server, and then from MCP server to any local resource or remote resource. So essentially, MCP server performs any action, any tool use on behalf of LLM, and it also provides the LLM the context of how to use that tool and what they do. And you can easily define your own MCP servers using Python or JavaScript or Java, whatever language you prefer. And over here, I have a simple MCP tool for running bash commands. So basically, it will just run the command, and that's pretty much it. You just need to wrap it into this MCP tool decorator, and this converts this piece of code into the MCP tool, which LLM can now use and perform any actions. And then you also will need server to JSON file with a way to run these commands. In this case, the command is Python and then the name of the file, because it's essentially just a Python script. But as we will see later, you can also use pretty much any MCP server. They could be Docker images, they could be NPM packages, and so on. So over here, let me switch to Agent with MCP notebook. And here I'm switching also from OpenAI to Anthropic model, just because Claude, at least before the 4.1 of GPT, Claude worked better with different tools, but now essentially OpenAI has also adopted the MCP protocol, so any MCP tool should work with any of either GPT-4 or Claude models. But over here, basically, I'm defining the client, which will help us interact with our MCP servers. Over here, it will just read the list of MCP tools from the server. So we will see that it's connected to the servers with different tools, and it will list the tools itself. And over here, we will just process a query. So essentially, it is the same message sending operation, which we've seen before with OpenAI GPT 4.1. So over here, we just define the list of tools, and we attach those available tools to the prompt, so LLM can decide if and what tools it wants to use to perform specific actions. So we provide name of the tool, we provide description, and we provide input schema for the tool itself. And then, based on the response from the LLM, we decide if that's a simple text, if that's a simple plain text response, or if that response is a tool use action. And if it is tool use, we will actually execute that tool, right? And then pass that information to LLM to act accordingly over here. So we will basically just essentially send the observation to LLM to give us hopefully the answer. And over here is the actual response from LLM. And here we have the chat loop, which basically just a syntactic sugar on top of that sending query or process query function. Now let's see that in action, and we will start with using just the bash tool, which I just shown a couple of seconds ago over here. It will just allow LLM to call any bash command. So we are connecting to the servers, and as you can see here, we are connected to the server with tools, with the tool called bash. And then we can ask LLM, for example, to list all files, in which case it decided to call the command ls-la, which makes sense. It got the answer from that command and gave us the summary of what it has seen in this directory. So it's a bunch of notebooks, a bunch of Python files, and so on. Let's see, we also can call multiple MCP tools at the same time. And over here, I have this sort of full JSON file, which defines 4 MCP servers. One is for manipulating the local file system over here. And as you can see, it is run as npm package. We also have web search, which is realized through Brave web search, and it is run as Docker. So basically, you can have MCP servers being run as different in different sort of flavors. It could be Docker images, it could be npm packages, it could be Python packages, and so on. We also have fetch tool, which allows LLM to fetch any URL. And we, of course, have our own bash tool over here, which is, again, a Python script. So let's, over here, see the LLM or the MCP client was able to connect to a few tools over here, which I just mentioned. It got a bunch of file manipulation tools or even directory manipulation tools, right? It can create directories, list directories, and so on. It can move files, it can do web search, and so on. And with that, we can essentially just ask LLM to perform any actions using those tools, right? So we can ask what's in Python 3.14 again, and it will do the web search. So we decided to call a Brave web search over here with those queries. Gave us the answer. We can also ask it to create a new file, for example. So let's see, create a new file, hello.txt, with content hello world, right? And it will hopefully decide to use a proper tool and will create a new file for us. So let's see, it decided to use the tool write file, which makes sense. And let's see if this file actually got created. Yeah, as we can see here, 11 seconds ago, this file got created and it contains what we requested. So essentially, LLM got access to your local computer indirectly, right, through sort of proxy. But it is now able to perform any actions on your local machine, and it could be anything from creating files all the way to running Docker images or whatnot. And let's actually see how we can now combine all of that into multi-agent collaboration, because of course tools are not necessarily just actual bash commands. It could be different agents as well. So you can basically build your own sort of hierarchical structure of different agents. So in this case, we will be building this supervisor and multiple agent structure where the user will interact with the supervisor, and then the supervisor will interact with different agents. The agents themselves won't be able to interact with each other, but of course you can also implement these as well. So now let's see this in action. And for that, I will switch to multi-agent notebook. Over here, I'm also introducing another layer of abstraction, namely length chain and length graph, just because it's it's easier to implement those things using those frameworks. But of course, you can also easily implement them on your own, because essentially it is just a bunch of structured inputs and outputs between different states of agent. So let's run the whole thing over here in the background. And basically what we are doing is, first of all, we are defining the same tools which we had before, like shell tool, we have the Brave search, we have file management, and we also adding a new tool called human tool, which basically would allow LLM to talk with us, with a human, and ask any clarification questions. Over here, we are defining our supervisor agent, which has access to those tools, and it also has access to 3 team members or 3 subordinate agents, namely front-end developer, back-end developer, and DevOps engineer. Here, we essentially just define the supervisor node, which has the structured output, and then can decide who it wants to delegate the next action to. It could be front-end developer, back-end developer again, and DevOps engineer. And also, if it decides that all is done, it can also do the finish call. And then we also define our subordinate agents, right? So virtual developers, basically, front-end agent. And we are just providing a simple prompt that it's a front-end developer. It can ask for help either from backend developer or DevOps engineer, or it can also ask for applications from the human client. The same goes with the backend developer, right? And the same goes with the DevOps agent over here, which can ask for any clarification again, either from human or from backend or front-end developers. So basically, typical small, I guess, team of virtual developers combined with a product manager, if you will. And this is how the actual graph will look like. Again, we have the supervisor, which interacts directly with all the subordinate agents, but the agents themselves, they only able to interact with supervisor. So if there is any handover from one agent to another, this needs to go through supervisor. But of course, you can also imagine those agents interacting with each other directly and delegating tasks from front-end developer to back-end developer directly. And the task, this is just a helper function for nice coloring of the output. And the task for them would be to build a conference website. It should have several pages. The front-end is in React, back-end in Fast API, and the PostgreSQL database as for storing the data. And as you can see here, it already went ahead and started doing something for us. So we decided first to pass on to front-end developer, and the front-end developer itself decided to run some bash commands, decided to install some packages, some Python packages as well, started to create in the directory for conference website. Let's actually see what's going on in our directory. Yeah, we already have this conference website directory, front-end, back-end. A lot of things already has been created for us. A lot of source code as well. Sorry. Yeah, so basically a lot of different output, and you can play around with on your own as well with that with those tools, and basically it will just create already, I guess, created some websites for us. Now, of course, it's always nice to play around with different tools and write the tools on your own, right? But you don't always have time for that. And of course, you can also start using agent without any effort already today, thanks to platforms like Zencoder. So let me briefly showcase what Zencoder can do. And Zencoder essentially is a plugin for VS Code or JetBrains, which incorporates a lot of agentic behavior already inside itself. Right, so you don't need to create these. You don't need to define those React frameworks and so on. You can just use agents right inside your IDE, and thanks to different integrations, you can, for example, directly mention the Jira ticket, ask Zencoder to solve it, do some Git manipulation, so create branch, check out, commit changes, and so on. And what I also like to do is instruct it to Slack me every time it is done with the task, so I get a lot of Slack messages from the bot, from the agents, basically. So let me go back to the output. So thanks to different tools, it was able to find the relevant files which it needs to modify. It performed some bash commands. So in this case, it created a Git branch, right? So it performed some changes in the files, a bunch of changes. I guess it slacked me. It created a commit message, added files, and so on. So basically, essentially, it performed or fixed a Jira ticket on your behalf, which is, of course, really nice. And the nice thing about this agent is that it also committed essentially from your behalf, not from itself. So you can take all the credits for the agent's work. And with that, now this kind of looks, I guess, for some, it looks a bit scary. And there are, of course, different views on what the future holds for the developers, right? So on the one hand, of course, there are people who think that AI will replace us, and you can think about it as both negative or positive thing, and maybe you can finally chase this dream of being a goose farmer after 22 years at Microsoft. when AI finally replace you or whatever your heart wants in your life. Now, of course, there are still AI is not able to train its own, right? It still requires data, so there is at least one job left for you to be, to be essentially data provider for the models to train on. But even if you doing vibe coding, right? If you still kind of need to understand what's going on, and that's the main issue with current models, at least with current generation of models. You can think about them as sort of junior or intern developers. They can write code, but they lack high-level understanding or creativity to understand what's going on. So basically, they won't be able to create an overall high-load architecture for you, but they would be able to help you. This is what we at Zencoder and me personally think about what's going to change going forward in our everyday developer work. Basically, we will become sort of managers of a bunch of virtual developers, virtual junior developers. We will be able to offload a lot of mundane or repetitive tasks to them. And us as developers, we would be able to focus on more creative, more high-level tasks instead. So essentially, the AI would be a true copilot for us rather than the replacement for the developers. Yeah, with that, a quick slide with a few QR codes. On the right, you can use QR code to connect to me if you have any questions left after the presentation, after the conference. And on the left, you have the QR code for our website where you can try us out for free.